Okay, this section is the last section of Chapter 5. This is 5.6, where the section's called Fit Align to Data. Now, what we've been working on for the last few sections is how to use equations to make lines and how to be able to write those equations if we're given the line. Today, we're going to use um, data from various things and being able to plot that data and use what is called the fit align. Um, get that data is through scatter plots. Now, scatter plots are used in graphs to determine whether the relationship between the paired data shows a trend, and they can and sometimes they do show a trend and sometimes they don't. If I let's see here, maybe I screwed up here. Let me just real quickly screw it, get my mix up, and let me save that. Oh, sorry about that. I just wanted to get the spell check out of the way. But there are when it comes to trends, there are three types of trends that represent a graph showing data. One of which is called a positive correlation. A positive correlation is if the y values tend to increase as the x values increase. So if we look, I'm using these little x's right here. Those represent specific data. I don't know what it is. These are just points that I plotted. And if you look, I have this red line going through the middle. That is an example of what is called a line to fit, because if you look, about the same amount of data on the top is also on the bottom. Let's see, there's what, 1 2 3 4 5 6 on the bottom, and 1 2 3 4 5 on the top. So it gives the line to fit, gives you an idea of what type of correlation it is. And since we look at the line and we can see that it has a positive slope, so we can make the conclusion that it has a positive correlation. The next type of relationship is a negative correlation. This is when the y value decreases as the x value decreases. Again, I'm using the same type of x to show some type of data. And again, here's our example of a line to fit where it is going in a negative slope. So since it's going in a negative slope, we can make the conclusion that it has a negative correlation. Now the last one is no correlation. If x and y values have no apparent relationship, the paired data is said to have a no correlation. So if you look at the data that I have represented here on the graph, I have data everywhere. There's no rhyme or reason of, I couldn't tell whether it was a positive or a negative one. And if you come across one of those in your graph, then you just say a no correlation is acceptable. Excuse me. So let's take a look at an example. So here's an example of some data, and I want to make a scatter plot of the data in the table. I want to draw a line of fit, and I want to write an equation of that line. So to be able to use the line of fit to model the data, we need to do some steps. So here's step one. first off, we must plot the data. Okay, so what I'm going to do is I look at it. All right, so I see I have x is 1, y is 3, so right there. X is 2, y is 5, so it's right there. X is 3, y is 6, it's right there. 4, y is 6. 5 and 7, and 6 and 9, and 8 and 10. So step 1 is done. I have plotted the data that was given for the example. Step 2 is we must determine where our line of fit goes. Okay, so like I said earlier, I want to have just as many points of data on top of my line of fit as below. So I'm going to do the best that I can to make a line here. I'm going to make it red. And let's see here. I'm going to see how close I can get this. We'll say that's close enough. So if you look at that line, there is, hold on a sec. Thank you. So I have, what, 1, 2, 3 points of data on top of the line. I have 1, 2, 3, 4 points of data on the bottom of the line. So at least for this example, I do have just as many on top as I do on the bottom. So um, as I let's look at step 3. So step 3 would be to write an equation for our line of fit. Now I understand that not everybody's going to have the same line. People are going to use different ways of rounding. You may want to be more precise. You may have decimals in your answer. You may have whole numbers. Well, putting those into consideration, I am more concerned about how close you are to the sample, to the sample data, rather than um, your actual drawing. I'm more concerned about if you got the right equation for the line of what line you drew, rather than maybe it being super precise. I hope that helps. So when we write the equation for the line, remember we're going to use the slope-intercept form, so it's y equals mx plus b. And as I look at it, I notice that my y-intercept, which is b, lands right on 0 comma negative 3. So that means my b, I'm going to scroll this down a little bit, it means my b equals 3. Now I need to find my slope. So if I know that I already have committed to making my y-intercept at 3, that means looks like it's crossing right here at um, 1 comma 4. And you can solve this one or two ways. You can count up, like I'm going to rise up 1 and I'm going to move to the right 1. So that means that my slope here is 1 over 1, which then equals 1. You could also use the equation for a slope and take 2 points and get something that is either 1 or very close to being 1. So I found my slope to be 1, and so that means that my equation for this line of fit will be y equals x plus 3. And that's it. That's the lesson. It's a matter of you guys collecting the data, using the data from the problems, drawing a graph, being able to plot those points, and then once you plot those points, giving yourself a line of fit to determine if it's a positive correlation, a negative correlation, or no correlation. And I hope I hope this helps. And this is the end of chapter 5. So I'll see you guys in chapter 6.